Okay, so now we are looking at modelling linear growth and decay, worksheet number 2. So the first thing we're going to look at is simple interest. So at the moment we've got Dylan, he's investing $6,000 in an investment account that pays 5.2% per annum simple interest. We're going to model this simple investment using a recurrence relation in the following form. Okay, so we've got our initial value is the principal value, okay, how much money Dylan is investing, okay, and then the next terms after that value, Vn add 1 equals Vn add D, where in this case, D, which is the common difference, it equals R divided by 100 multiplied by the initial value. Now that R represents the interest rate, okay, of 5.2%. Your question is, how do we work this out? Well, first of all, we need to look at the common difference formula. Okay, we've got the common difference equals the rate divided by 100 multiplied by the initial value. We substitute the values we know, okay, so they are highlighted in black. Okay, 5.2 divided by 100 multiplied by 6,000. Okay, we use our class pad to calculate that and we end up getting 312. So that represents the difference between each term. Okay, now we can model this investment. Okay, so the recurrence relation is the initial value equals $6,000 and each term after that we're adding $312. Okay, so that is pretty much it for question number 1. Now, Dylan's simple interest investment is modelled by, and sometimes with these questions, as you can see, you are provided with the solution from the previous question. So this occurs all the time when it comes to the exams, okay? So this occurs when or where Vn is the value of the investment after n years. So A, we're going to use the model to determine the value of Dylan's investment after 3 years. So let's have a look at what we have to do. Okay, V0 equals 6,000. Now, the best way to model these type of questions is actually showing the working, as you can see there. So V1, which is the next term, equals 6,000 add 312. Okay, and therefore we get $6,312. Now what we're going to do is keep using that value for the next term. Okay, V2 equals $6,312 and we're adding $312 again. And now we get $6,624. Now, the question is asking for 3 years, so we have to do it one more time. Okay, V3 equals $6,624, add 312, and we end up getting $6,936. Okay, and that's basically it. That's how we use our recurrence relation to model these types of problems. Okay, 2B, when will Dylan's investment first exceed $7,000? Okay, so we got B4. As you might already know, we are actually adding $312 each time. So you would have seen from the previous question, we're at $6,936. We're pretty close to $7,000 as it is. Okay, so we're just going to go to the next term. And therefore at V4, it equals $7,248. Okay, and that represents the 4th year. So Dylan's investment first exceeds $7,000 after the 4th year. Okay. Now let's have a look at flat rate depreciation. Okay, so the difference between this and what we did previously with simple interest, we are going to be subtracting the common difference value. Okay, so in this case, we've got a new motorbike was purchased for $21,000. The motorbike depreciates by 15% of its purchase price each year. Model the depreciation value of this motorbike using a recurrence relation in the following form. Okay, so this time we've got V0, or the initial value. Okay, that's the initial value of the asset. In this case, it's the motorbike. Then it's modelled by V, n add 1 equals Vn, subtract D. Okay, as you can see, the formula for the common difference is exactly the same. So we just do exactly the same as what we did before. First step, we have a look at the formula. Now we substitute the values, okay? We've got 15%, okay? So 15 divided by 100 multiplied by 21,000, okay? We work that out, we end up getting 3,150. Now we can put it in the recurrence relation, okay? So the recurrence relation is, the initial value is $21,000, and now we have V, and add 1 equals Vn, subtract 3,150, okay? So we're ready to go. Okay, with 4, as you can see there, we can check our solution to see if we are correct, and in this case we are. Yay! Very good. Okay, this time we have to use the model to determine the value of the motorbike after 3 years. So we just do this again, okay? The initial value was $21,000. Now we're subtracting by $3,150 each time, okay? So now the next term is $17,850. We do it again, we use the previous term, and we're subtracting $3,150 again. Okay, $14,700. Now if you like, with the working out, you can use a substitute for the previous value. So for example, V3 can also equal V2 subtract 3,150. Okay, you can write it in that notation. Okay, it's exactly the same thing. So V3 equals $14,700 subtract $3,150. And what do we get? $11,550. Okay, so that is the value after 3 years. Oh, now, when will the value of the motorbike fall below $3,000? Now, the value of the motorbike falls below $3,000 after 6 years. Now, as you can see, the solution suddenly came up there. What I'm going to do is actually show you how we find that. Okay, the best way with this is actually using the class pad. So what I'm going to do is move it across here, and I'm going to go to menu and then sequence. Okay, we've done this before. This time I'm putting in the recurrence relation. Okay, so this time we got AN. We're subtracting 3,150. And this time we got $21,000. Okay, we make sure we tick that. Now, before we start, it's probably good to work out where we're going to start from, but we can just select the table. Okay, so here we're going all the way up to 4. So what I'm going to do is just change that to show when does it actually fall below $3,000. So I'm going to click where you see the X and Y to change the sequence table input. I'm going to change the end. Now I usually go to 10, okay, just to be on the safe side. And as you can see, we have to keep going all the way down, and we get to N equals 6, okay, or V6 equals $2,100. So therefore it is below $3,000 after 6 years, okay. So that is the way you can work these out using the class pad. Okay, next thing we're looking at unit cost depreciation. So we've got Andre, he is a gamer. Now he purchased a PlayStation or PS4 for $700. The PlayStation depreciates in value by 5 cents each time it is used. Model the depreciation value of this PlayStation using a recurrence relation in the form. Okay, as you can see, it's exactly the same before, except for the common difference is the depreciation in value per use. Okay, so the first thing we're looking at is Vn is the value of the PlayStation after n number of games. Now, the common difference is now going to be 5 cents. Now, what you have to do is convert it into dollars. Okay, make sure the units are consistent. 5 cents in dollars is 0.05. Okay, now we've got our common difference straight away. We can put it into the recurrence relation, as you can see here. It is the initial value equals $700, and then each term after that we're subtracting by 0.05. Now the depreciation value of the PlayStation is modelled by, again, we can check our solution. Now we know we're correct. Okay, let's use the model to determine the value of Andre's PlayStation after 5 games. Now what I might do now is go to the class pad, edit what I did before. Okay, clear all. And now I'm going to put in the new recurrence relation and actually model it using my class pad. Okay, you can do this manually if you like. So AN subtract 0.05. Okay, initial value is $700. And we're going to do a table. And in this case, we've got 0 to 5. Now, the really good thing about this is it actually uses the same values I used before. So n equals 0 all the way down to n equals 10. Okay, so now we just look at what happens after 5 games. We get $699.75. Okay, so that's our solution there. But what I'm going to do is just scroll up. And what we do have to do is actually input those values in, showing our working out. So this is all from the class pad. And as you can see there, okay, $699.75. So it's exactly the same. The value of the PlayStation after 5 games is $699.75. That's what you write. And once again, the class pad is your friend. Okay, so thank you for watching the video, and if you've got any more questions, feel free to contact me. Okay, thank you.